Hi, this is Nathan Tinsel. In this video, we're going to talk about how the 6 steps of a statistical investigation apply to a particular statistical study. The example we'll use is the organ donation example from the Introduction to Statistical Investigations textbook. So what are the 6 steps of a statistical investigation? We'll start there, we'll go over these briefly, and then we'll apply them to the organ donation example. The first step of a statistical investigation is to ask a research question that can be addressed by collecting data. These questions often involve comparing groups, asking whether something affects something else, or assessing people's opinions. The second step is to design a study and collect data. This step involves selecting the people or objects to be studied and deciding how to gather relevant data on them. The third step involves exploring the data. In this step, the researchers are looking for patterns related to the research question, as well as unexpected outcomes that might point to additional questions to pursue. In step 4, researchers are going to draw inferences beyond the data by determining whether any findings in the data reflect a genuine tendency, and then also to estimate the size of that tendency. In step 5, researchers are formulating conclusions that consider the scope of the inference that was made in step 4. To what underlying process or to what bigger group can these conclusions be generalized? And is a cause and effect conclusion warranted? Finally, in step 6, researchers look back and ahead. They look back at the study and say, what were limitations of the study? What could we have done differently or better? And then they look forward and they suggest new studies that could be performed to build on the findings of the current study. So let's apply those 6 steps now to the organ donation example. So the first thing the researchers did in the organ donation study is they had a general question. They asked themselves, is there a method which will increase the likelihood that a person agrees to become an organ donor? Then they refined that question down. They got more focused by saying, does the way we ask the question on a driver's license renewal form impact the way, the likelihood that someone becomes an organ donor? Having taken a broad question and narrowed it down, the researchers then designed the study. They asked volunteers to pretend to apply for a license, and they had 161 volunteers participate. The participants didn't know that different versions of the survey existed or what the purpose of the study was. And participants were offered $4 to participate. After the researchers administered the surveys and gathered the data, they removed some low-quality data, some people who had replied multiple times or took less than only a few seconds to participate. In step 3, the researchers started exploring the data. They found that of the 56 participants in the neutral group, 44 of them, that's 78.6%, agreed to become organ donors. In the opt-in group, these were folks who had to check a box to actively decide that they wanted to be organ donors. 23 out of 55 of those in the opt-in group agreed to become organ donors. That's only 41.8%. In the third group, this was the opt-out group, these were individuals who had to check a box to say, no, I don't want to be an organ donor. 82% of these individuals, that's 41 out of 50, agreed to become organ donors. When you're exploring the data, often researchers will use a mix of numerical and graphical summaries. I've just shared with you some numerical summaries. Here's a graphical summary that shows you a bar chart showing where the height of the bars indicates to you the likelihood that individuals in the different groups indicate that they wish to become organ donors. From this graph, we can see that the opt-out and neutral group are substantially higher than the opt-in group. In step 4, the researchers now go beyond the data. We've just talked about the data we had. Now the question is, what does that mean? Well, as it turns out, using techniques that we're going to learn later in the course, the observed differences between the groups were large enough to suggest that the default option had a genuine effect. And then researchers went on and they estimated the impact. And again, using techniques we're going to learn in later chapters, the researchers argued that between 20 and 54% more individuals would become organ donors if states used the neutral version of the question instead of the opt-in version, which is used by most states currently. Based on the analysis and design of the study, the researchers concluded that the change in wording causes an increase in participation of donors. It's not just an association, it's a causation. Additionally, the researchers concluded that the only way they could generalize conclusions beyond the 161 volunteers in the study was if those participants in the study were representative of a larger group of people. Both of these conclusions are things we're going to talk more about in later chapters as well. Finally, in step 6, the researchers looked back and ahead. They looked back and they identified a series of limitations of their study. First and foremost, this was not actual people who were obtaining a driver's license. This was asking people, hypothetically, if you were obtaining a driver's license, what would you do? Second limitation, the researchers only compared 3 different wording strategies. They didn't consider other options for increasing the number of organ donors. Maybe an educational campaign would be worthwhile to sort of evaluate how many organ donors you would get if you were telling more people that organ donation is a good idea and it's necessary. Another limitation, we don't know much about the volunteers. These particular 161 people who participated may have a limited demographic profile. If they are all males over the age of 60, that's going to tell us something different than if they represent a wide variety of genders, ages, and ethnicities. Another thing the researchers did was they looked at other studies like theirs that had been done. A similar study had been done in Europe only a couple of years prior and found very similar things. Interestingly, another study had been done in the United States a number of years earlier where they did not find large differences. Overall, the 6 steps of the statistical investigation process can be thought of like a flowchart like this, where we're sort of moving from asking a research question to designing a study, exploring the data, drawing inferences, formulating conclusions, and then looking back and ahead. And in research, when you look back and ahead, you're often then suggesting additional research questions that may be asked in the future. A couple of areas of caution before we end. First, a lot of students think that statistics is number crunching. I'm going to push a button on the calculator, I'm going to get a percentage, or I'll calculate the average of the set of numbers. One thing we want you to know right from the get-go is that statistics is a lot more than number crunching. It's really a process, and we've characterized it as a 6-step process that sort of comes alongside any research project, research question. Secondly, most studies are doing all 6 steps, even if they don't say so. In the media, you often hear just a number. You don't know, how did those researchers get that number? Who participated in that survey? What questions were asked? How did potentially the phrasing of those questions impact the way people responded? And there's a whole host of questions that when we hear statistics in everyday use, we don't get sort of access to all 6 steps at once. And so one of the things we want to help you understand is when you hear one number out of context or someone drawing a conclusion out of context, some of the other key questions to ask to help critically evaluate the information we hear each day. And with that, we've talked about the 6 steps of the statistical investigation method and how they apply to the organ donation example.